Let's get started with some all your multiple choice that I'll explain as I go through that, explain why the answers that they're given the answers, why not yours. Start with question 1. A mixture of the sand, salt, oil, and water needs to separate it into the 4 individuals too. Okay. By the way, if you realize that the questions are very similar to the practice 1 paper too, even the structure, the order of the question, I did the same. I just changed the words and some example and descriptions too. For that, the answer is C, obviously, that we need to separating the sand, salt, and oil and the water. So using the physical property differences, it's basically how we separate the mixture using the physical properties. Sand and salt is soluble, water is in the water, oil in water is immiscible. They are not mixing together as two. Sand is much denser than any of the oil. So we were expecting that if you're mixing everything, sand will be basically at the bottom of the mixture and followed by the salt water and oil on the top. So to perfectly and efficiently separating them, we have to perform the filtrations, followed by the separating funnel and the distillation to get the all the things out. Now, we don't do the evaporation and distillation in the 2 orders because evaporation is basically happens with the distillation itself. If you do distillation, you eventually get evaporated. So the answer is C in that reasons. No decantation again too. I probably said like 2 weeks ago. Decantation is the least efficient techniques we do because it wasn't separating that. And as you do decanting them with the oil, the sand would have some with the oil as well too. Then it's not a proper mix separating the mixture. Yep.
Oh, I think that's the wrong one.
Oh, the paper one. No wonder paper is exactly the same. Sorry. This one, wasn't it? Okay, let me just change that. What, the still answer to say for that one too.
Wait, what's decantation and crystallization?
Crystallization is simply like another term we're using for the evaporation itself too. We're crystallizing the salt by evaporating the water. Decantation is we're using the glass straw to gently removing the water out of the solid. And as you can expect, it's not going to be like that accurate to do it.
Wait, how do you crystallize the liquid?
No, we don't crystallize liquid. We crystallize the salt in the liquid or the salt water.
How?
You get what I mean?
How?
Evaporate it.
What, if you evaporate it?
Salt water. What do you get?
Salt.
Yeah, salt is the crystal.
Oh.
Thank you. Okay, easy.
So that's like the opposite of distillation.
Yeah. Why do we distillate? For what? For to get what? Pure. Why do we distillate the salt water? To get what? Water. Why do we evaporate the water? To get what? Salt. That's a 2. By using the same physical property of the boiling point differences too.
Wait, so if you chose so crystallization and distillation would be like very similar.
Yeah, I mean, I would say evaporation and crystallization is the similar or the same. The distillation and evaporation, it's not the same. Depends on what you want to get out of that.
What's the difference between distillation and fractional distillation?
Good point. Fractional distillation is that we're using, if you have a mixture of the liquid, like a crude oil is a good example of that too. It has a lot of the different boiling point mixtures. For example, petrols or the gasolines or some gases then too. To fractionally, in step by step we distillated, we're using the fraction chamber that look like really long chambers too. And basically putting the oil over here, you are boiling that. And depends on the boiling points you will have, it's going to fractionally get distillated.
It does that?
Yeah, it does that. Yeah, this is basically how we get the gas, the natural gas, get the petrol, which is a fine like a petrols too, or some dirt or the aspirates are coming too.
On the way up, right, for example, the top one.
Yeah.
Why doesn't it go to the bottom on the way up?
Oh, because they have a fraction like a membranes are given to. It's engineers. So a key point of that is if we have a mixture of that something, if we try to separate the mixture with the various boiling points, we are using the fractional distillation like that. Another example would be like if a mixture of the water and ethanol with something else too. We can do the fractional distillation as well because ethanol would have the lower boiling point of the water. So as we boil in the mixture of the ethanol will be evaporated first. We collect them out.
Wait, so would it be like, for example, the bottom one is water?
Yeah.
Then water gets like that first?
Yeah.
And then once...
So for example, I can say we have a water, ethanol, which is alcohol. Let's say we have a gas, some CO2 gas. Kind of mixed all together too. It could be like some alcohol beverages, it would be like things like this too. Then, as we evaporate that gas, which has the lowest boiling point will be, goes up and evaporated comes out first of all. Or it comes to the segments, comes out too. Once all the CO2 gets removed, then we are increasing the temperature to remove the ethanol from that. Because the boiling point of ethanol is around the 60 degrees Celsius, CO2 would be minus like a 25 degrees Celsius too, that would be 100 degrees Celsius. Which means that by doing you set up your temperature of the chamber, it's only those will be evaporated as by the two, the fractionally. Make sense? That's called the fractional distillation itself. All good? Part B, question 2. Chromium. I've been warning you to like memorize some exceptions of the SPDF, chromium and copper. Chromium is the ones that has a 3D5 and 4S1. Just look at the last numbers too. Therefore, answers B. All good? 3. Element has the following consecutive ionized energies too. Have you seen like we have the relatively low first and the second, followed by the really high third and fourth. This kind of telling that as the ionization energy means that energy required to remove the electrons too, it takes the less amount of energy for the first and second, means that highly likely there are 2 valence electrons in the last shells. So group 2 is highly likely to be the answer in that reasons. It has the lower, the second ionized energy and increase the third. 4. The brick red flame test. Even though you may or may not be learning that too in year 11, but I recommend you to memorize some flame color tests, flame test colors. The brick red is a signature color of the calcium. So it's giving that B in the straight away, the answer. There's no shortcut. You need to memorize the colors anyways too for the year 12 as well too. All good? Copper is like, and the copper is not red. Copper is more like a bluish green, a greenish blue. Potassium is a lilac, chromium is crimson, and sodium is yellow. We have strontium is crimson, sorry. The barium is the apple green. We described that. Yeah. Yeah, and then you may need to memorize them all as you go. 5. Which of the following molecule has the trigonal pyramidal geometry according to the Vesper theory? So trigonal pyramidal is the unbalanced too. So you may draw that, but if you memorize some of the structures too, it's actually pretty easy to do it. Trigonal pyramidals, ammonia, typical one that we have discussed a lot too. Ammonia has the 3, look like this, 3 hydrogen attack with the 1 lone pair. If you remember that, having the 4 attachments, fundamental shape of the tetrahedral, having the 1 lone pair, making the from 4 trigonal pyramidal shape the 2. So the ammonia is the one that too. Or you can just memorize some of this typical example given. 6. Which list correctly orders the substance from the lowest to the highest melting point? The key point of this question is that you need to figure it out, one, the understanding of the intramolecular forces and intermolecular forces given too. So having that lowest would have been the lower, some dispersion force only. Now remember, dispersion force is the weakest intermolecular force, followed by the dipole-dipoles. That's between covalent and polar covalent bondings. So out of the CO2, H2O, silicon oxide, and sodium chloride too, it is the A. Chlorine has the lowest boiling point as the dispersion force existed. H2O has the hydrogen bonding. But sodium chloride, I think that's what we discussed the last week too, in terms of the week before. Ionic compound has lower boiling point than covalent compound network. Silicon dioxide is the covalent network, and sodium chloride is the ionic network too. Good to memorize that, because they won't be given on your formula sheet. Just you need to use your skills and understanding of this. 7, we have given 17 grams of ammonia. So how many hydrogen atoms? One thing you have to understand, ammonia, per 1 ammonia has 3 hydrogen. So N of the hydrogen is same as it, 3 times N of the ammonia. It'll be like that. Understood? If I have 1 ammonia, I have 3 hydrogens. That's how we're going to do the mathematical terms too. N is then equals to what? Mass over molar mass of the everything's too. Doing your calculations, just using that M over mass molar mass, that too. Use your calculator, you get answer B.
Wait,
Oh, sorry. N hydrogen, the total number is N of the hydrogen times the Avogadro's number, which is 6.02 to 10 to the power 23. Yep, Brian. Question? Do you understand that?
What is 1 mole of hydrogen equal?
No, number of the hydrogen equals to the 3 times the number of the ammonia hydrogen. How many hydrogens in 1 ammonia? 3. Therefore that. As you said, 1 ammonia had 3 hydrogens. 2, 6, 3, 9 in the orders of that too. Okay, be familiar yourself to writing down the method like this. It's a bit mathematical, but still, it's a really useful tool. So you know, it shows like all the summaries of the what the question, summarizing all the points of the questions asking you to. 8, 40% to carbon, 6.7% hydrogens to 53.3%. You can use a table method, or either you can use the end of the method too. Empirical formula, then you're to get answer B. Any questions for the how to find the empirical formula, guys? Percentage divided by molar mass of the mass number of that too. You get the number of moles, and that times that, or you can make an assumption that 400 grams. If you're not too sure,
B.
8. Oh, sorry, wrong answer. My bad. It's A. 8A, yes. Next one. 9. Nitrogen and hydrogen gas reacted to 2 liters of that. So now, as we're giving all gases and 2 liters and 6 liters, if you remember this is the law known as the Gay-Lussac's, the volume and to the mole law, that we can now taking the volume of the gas as the mole ratio too. So 2 liter nitrogen gas with the 6 hydrogen. Now, have a consider about, we have a 1:3 reaction ratio between N2 and H2. Having 2 nitrogen requires a 6, which we have it. So there's no limiting reagent in case of this. This would have produced that then 4 liter of the ammonia, according to the reaction ratio of the 1:2. Therefore, answer for 9 is B. Do you get what I'm trying to say in here?
No.
Do you understand the meaning of the Avogadro's same gas volume law? The number mole is not be changed. So volume in the gas is treated as same proportion N in the gas. They're direct proportional to each other's too. I'll come back to you, okay? Therefore, from, as we know, the 2 liters too, we are considering that they are sharing the same molar ratio in terms of they can find the values. Do your revisions, you better do it.
No, I know what it means.
Good, yeah?
Wait, but if it reacts completely and it's like.
Yeah.
What is it? It's like 2 plus 6.
2 plus what?
2 plus 6.
Well, they're completely reacted, so they're removed. There's no more reactants, only be products formed.
But like, you know, like the rule where like nothing can be like destroyed or
They're not
the law of
destroyed.
conservation of mass, right?
Oh, it's not mass, it's a volume. Mass is still the same. The volume is different, the mass is the same. What? Okay, guys, volume is not mass. They are all completely different terms. They're completely different. We can have a same volume. I can prove that. Like, have a think about, like, Kirsty, have a think about it. I have a liter of ethanol, alcohol, compared to a liter of the water. Would they have the same mass? No, they have a different mass due to their densities. Same in here. I can have the 1 cubic square meter of the iron and 1 cubic square meter of the carbon. Sean, would they have the same mass? No. No, they have a different mass because the iron would be heavier. Yeah? What you think about on the ball, like you have a basketball and the soccer balls too, like same volume. They're different as well too. Depends on what materials you made. 10. Which of the following molecule contains a polar covalent bonds? Okay, Brian, how do we determine the presence of the polar covalent bonds?
Polar covalent bonds.
Yeah. What it doesn't mean by polar covalent bonds?
They're unequal.
Unequal.
In electronegativity.
Yeah. Therefore,
it's polar covalent.
oh no, you skipped too much. You gave me the introduction and you jumped to the conclusion straight away.
Dipole and positive dipole.
Why is a dipole created?
Because it's unequal. It's metal and non-metal.
It's not, that's ionic.
Non-metal and non-metal.
Yeah, the difference in electronegativity. Write this one down, guys. This is a summary of the revision of the audio module 1 contents 2. If we have a massive difference in electronegativity, there's actually numbers will be given to. We say like some 1 or 2. But if we have a significant, I must say it, the difference in the electronegativity between two non-metal elements. Now, you have to understand the terminal called the electronegativity then here. Electronegativity is all about the power of the tendency of the gaining electrons too. So I've been giving you a lot of times the hydrogen, oxygen too. They will still share the electron. That's the difference between ionic to the covalent. Hydrogen still have some share of the electron itself too, but when they're sharing, they will be forming the very unequal share of the electrons too. In other words, the one has a stronger, the greater electronegativity takes all the percentage of the electron itself, getting itself to be partially negative. So you may understand that as the more electronegative, the element becomes the partially negative. We call that as partially negative. The less electronegative element becomes partially positive. Partially positive like this too. Now having these two, having the partially negative and partially positive is we call that dipole. And the bonding is now being known as the polar covalent bonding. And the vice versa. If we have not much insignificant difference in the electronegativity then too. Have a think about here. If there's an insignificant, not much difference in electronegativity. Okay? Alex, what do you expect? If we have an insignificant difference in electronegativity between two nonmetals. So what would be the sharing of the electrons? Equal sharing. Would there be any polarities formed then? No, there'll be no dipole be generated. That's the time we call it as non-polar covalent bondings. Yep.
Is that completely no dipole? Is there like a little?
There'll be little, but it's negligibly like dipoles too.
So what's the cutoff?
The cutoff would be carbon and hydrogen, in between the carbon and hydrogens. Hydrogen, you can understand that as hydrogen has the lowest electronegativity among the non-metal sections too, and followed by the carbon. So you may say like last place is the hydrogen, and second last is the carbons too. So between the second last and last, carbon and hydrogen, we form the slightly polar, but that's really negligibly polar. But in between carbon and oxygen, now think about those three: fluorine, oxygen, and fluorine, oxygen, and nitrogen. They are number 1, 2, 3. Gold, silver, and bronze metals that I described the two. They has the greatest electronegativities too. So any combination between F or N to the hydrogen, they would creating the greatest dipole. So we're giving the very special name of that intermolecular force to be hydrogen bondings too. Please summarize all this. This is the terms that even if you forget about, even if you forget about Vespa, Lewis dot diagram, I don't mind. Because you only get it twice in your life. I don't know, maybe in year 11. If you're studying chemistry in uni, that's a different story too. But I talk about high school life. You only get it twice. One is the coming up exam this term, or the half yearly, and the yearly exam. You won't get those SPDF or Vespa theory back in year 12. I guarantee that. But intra, until you finish the HSC, no, the last day to finish the HSC, you will get these questions back into. Because we're dealing with a lot of the carbon chemistry called the organic chemistry in module 7. It'll be fun. Yes, Kirsty?
So between oxygen and sulfur, which one's stronger?
Oxygen is technically stronger following to the periodicity trend. As you remember, like going up the group, strong electronegativities too. But in between two, they are not really like significant differences too. So they are sulfur and oxygen. So for this, going back to the question then too, the one has the which 10 polar covalent bonds but non-polar molecules overall. Now, started with defining the polar covalent bond. H2O is polar covalent bond. CCl4 carbon tetrachloride is a polar covalent bond too. NH3 polar covalent bond, HCl polar covalent bonds. But which would not be the non-polar molecules and structures too? Sean, what was the 3 structures that is a non-polar in Vespa theory? Non-polar. Shall we start from here? I can make a table too. So all the two. So Vespa theory, the structure. What's the structure of the H2O? So what's the structure? Bent. What's the CCl4? Tetrahedral. NH3, pyramidal. HCl, linear. But linear with the exposed HCl, dipole, partial negative, partial positive, that gives us 2. Now, from these 4, which is the non-polar structure? Do you remember the symmetry equals to? Symmetry or asymmetry too? Bent is asymmetry, so this is the polar structure. Tetrahedral is symmetry, so this is known as the non-polar molecule structures. Pyramidal shape is the asymmetry, so therefore it's another like the shape of the polar. Bent is technically symmetry, but as we have a H and Cl being exposed to, even though it's a symmetry having another 2, it will have some dipoles be created. So the correct answer is therefore B. Yep. 11. What volume of the concentrated 10 mole per liter hydrochloric acid is required to prepare 2 liters that? Basically, C1V equals C2V2, the dilution factors too. So 11, therefore answer C. Easy. Yeah. Any question for 11? 12. Parts per million, the unit of the milligram. ppm is the unit for the milligram per the liter, or the milligram for the kilograms too. I ask you to memorize this unit until you finish HSC. You're actually going to get it in HSC as well too. Yeah. So in terms of giving everything here, 500 ml sample groundwater content of that too. So in the concentrations, and it's a given a density, so we don't have to worry with the densities too. Start with the concentration of this sample is the mass of a volume, 0.015 grams on the 500 milliliters, 0.5 liters like this. Isn't that the same as 0.15 times 10 to the power negative 3, 10 to the power 3, sorry, milligrams over 0.5 liters like this? So you have a unit, milligram per liters, matched up units too. Use your calculator, you get the final answer, 11. I'm 12, sorry, therefore B, which is 30 ppm. 13, which graph? Why?
I'm gonna route with this. I'm gonna go with this one.
Move on, okay. Boyle's law is pressure of the ideal gas of the constant temperatures to. The answer is C, the curve with the decrease in negative slope, hyperbola. Why? Boyle's law is the ones that BP, volume and pressure are inversely proportional. We get the hyperbola shape or the parabolic shape. Okay. 14. When the preparing standard solutions of that, hang on the ideal gas and the constant volumes too. 13. Answer could be wrong. So volume and pressure is inversely proportional like this, which means during the volume and the P, it goes like this. No. Hyperbola. Yeah. No. I'm getting confused. No, this. Yeah. Yeah, C, 13. Move on. 14. When preparing the standard solution from the solid primary standard, which of the following items the glass was essential to make the final concentration to? I hope you remember like those tools that we have used in the prac. It's called the volumetric flask. Duh, not beaker. Yeah. Therefore, B is the answer.
What's the difference between volumetric flask and conical flask?
I show you that in the lab later too. Conical flask, volumetric flask.
Is the only reason why the volumetric flask is important, is it because we can shake it?
No, because the volumetric flask is actually having the marker giving the actual volume of the 250 mils or 100 mils.
The measuring cylinder does too.
Oh, what about the measuring cylinder uncertainties?
What uncertainties?
Would you like to, how are you going to shake the measuring cylinder?
Wait,
We never make the standard solution. Yeah, what uncertainties? Do you know the uncertainty of the measuring cylinder is plus minus 2 milliliters every per measurement? That means you try to measure 100 mils, you actually can get up to 102 or 98 mils.
Why do we still use it?
We don't use it. Did we use it?
No, but why do schools still
Well, we use it if we needed to, like if we weren't concerning about the uncertainties. But did we use it for to make the standard solutions? Why didn't we use it? My turn.
Huh?
Why didn't we use that then?
To limit errors.
Why? What was the aim of the experiment?
To get the certain amount of moles.
Why? You're not answering my question properly now. What's the aim of the experiment?
To ensure the final concentration is highly accurate.
Yeah, which is we call that what solution?
Oxalic.
No.
What?
The solution that we know the exact concentration is called?
Sodium.
No.
What?
The solution that we know the exact concentration, it's actually given over here though. It's called the standard solutions to. Yeah, so to make the standard solution, let's summarize that. To make the standard solution, we need to use the appropriate, really accurate tools like the pipettes or the volumetric flasks, not those conical flasks, beaker, measuring cylinders in that reasons too, because we need to know exact concentration of that solution we made.
Wait, what if the measuring cylinder has super accurate?
Impossible. Unless you're using the, there are some now in some university labs, we're using the digitalized measuring cylinder. Unless you're using that.
Okay, but why is volumetric flask so accurate?
Because they engineered the shape of the volumetric flask to be super accurate too. Yeah.
But isn't like the width of the measuring cylinder and the volumetric flask the same?
No?
But some are.
Yeah, but that's super inaccurate to using that kind of measuring cylinder too. Have you tried to measure like a 5 mils with using a measuring cylinder, by the way?
No.
Well, 1 mil,
No.
25 mils, it's extremely difficult to do it. One of the reasons why we don't use the measuring cylinder is, once you pour so much amount, how are you going to remove that if you pour extra? you're gonna tip it over. But during that process, you got some residuals left over as well too. Did we have that in on the volumetric flask? I've been asking you to be very careful with not go exceeding the line.
Use the pipette.
We used to even use the pipette, but in volumetric flask, you have a line at the neck over here. If ever goes above, that's screwed. I mean, like ask, that's not the exact concentration now. So, what's our technique? What kind of accurate? Yeah, I think I try to push it to be accurate too. Even if like you made lots of random errors, like tilting over, having some laughing, and I hope you had a fun. But you know, if you had any exam questions about that, it's not going to be fun. Like this guy telling me, what's the difference between conical flask and volumetric flask? Because you asked me the same question last time too. Yeah, you actually do. Remember, volumetric is rounder, and conical flask would be the cone shape. That's all I can give you, like the visualization. Yeah. Well, yeah, but did we use to measure something? Oh. I remember you now. You and Kirsty was yelling at you. Kirsty was like, what are you doing, bro? What are you doing, bro? Half of that she was yelling, what are you doing, bro? Not even short, bro, what are you doing? What are you doing? Yeah, she was, it's not. You see when we do the titration again, okay? All right, by the way, module 3, yeah, we're gonna do a set of some pracs. So we actually gotta make some precipitations and combustion reactions. We're gonna kind of do some investigation later on too, but we'll see. 17, 12 liters, 25 degrees Celsius, and 100 kilopascal. Remember that 25 degrees Celsius and 100 kilopascal is known as the SLC. So you use the molar volume of the 24.79 liter per mole. I've been asked you to memorize the value, even though all the conditions too. So using that, 12 liters it can be converted into, remember, the N is equals to volume divided by molar volume at the SLC like this. We did some gas flow questions a lot. And if the temperatures increase, but we don't have to use it, sorry. Given that 50 degrees Celsius to 200 kilopascal. Now, given the temperature change, but one thing is not really changing the number of moles. So this is very useful to use combined, preferably using combined gas flow rather using the ideal gas laws too, which is giving the P1 over T1 equals 2, P2 V2 over T2 here like this, because the rest of the condition is not being changed, and just substitute the value. But one thing that you should do is convert the temperature into the Kelvin. 25 plus 275.15 to 98.15 like this. T2 is therefore 323.15 Kelvin. If you didn't convert the unit to the Kelvin, you will get a completely different answer in this case. Therefore, answer for 15 is B, 6.50 liter. 16. Which isotope is the lowest likely to undergo alpha decay? This is for you, Sean. Which would go to alpha decay? When do we get the alpha, beta, and gamma decays there? Do you remember the second lesson, second or third, that I gave a really detailed depth about? In certain circumstances, they're going through the alpha. Certain circumstances, they go to beta too. So giving a little summary of that, I can summarize on this board here. Yep. Oh, I heard something. Good. Alpha decay. Alpha is basically a helium nucleus. That's ejecting that 4 to helium, or the 4 to alpha is substitute 2. Now this, you have to understand that all the decay series as like in the nucleus, in the atoms, they're very unstable for some reasons too. Stability of nucleus is achieved by the balanced number of the neutrons and the protons. Proton has the property of the pulling out, going outward from the nucleus. Neutrons are the ones that gluing them together. So without the neutrons, proton will be ejected out a lot of times too. Now, alpha decay occurs for the heavy, generally for a heavy element, heavier than the lead in general too. Like a uranium is a good example too. And this is the case that when there are too many protons than the required neutrons too. trust me, not many chemistry teachers can explain in depth because this is the physics behind the two, in terms of understanding some electrostatic forces behind the two. But understanding that it's much easier to understand the alpha decays too. So the requirement is then we need to have a heavy element, like heavier than the lead, and the number of the proton is then greater than the proton number. Then how do we know the required neutron numbers? This is why you got given your periodic table. Periodic table is the one giving the standard balanced number of the proton and neutrons too. So if I just comparing the numbers from that, if you have less mass number than required givens too, that's highly likely to be going through the alpha decays too. So in this case, therefore, carbon 14, cobalt 16, but I ask you to memorize all that too. If you did, you would find that uranium 238, it would be highly likely to be going through the alpha decay in this case. By the way, carbon 14 would go through the beta decay. Cobalt 60 undergoes the beta decay. Technetium 1998 is known as the rejecting D. Thank you. This has got to be in your exam. 17. Experiment. 4 moles of the solid magnesium are reacted with 6 moles of the aqueous hydrochloric acid. So, just limiting reagent questions. If you did well, so you would get answer B, hydrochloric acid, and 3 moles of the H2 will be produced. Okay, mass of the one molecule, not mole, molecules that givens too. So it's kind of confused, but we had the same question in the paper 1 as well too. So I started with mass of the one molecule. So molar mass of the SO2 is given that you can find that 64.07 gram per mole. To find the mass of the one molecules, you have to understand that 64.07 molar mass divided by the, basically we can divide it by mm on the Na, Avogadro's number like this, as N equals to m over molar mass, and N is also the same as what? The number mole divided by Na here like this. As we have 1, we can just do mathematically too. You can substitute the value. So this is giving m over molar mass is same as the 1 over Na in this forms too. So therefore, you get m is equals to molar mass divided by Na. This is a proof of using the formulas. But by just dividing these the Avogadro's numbers too, you get 1.06 times 10 to the power minus 22. Therefore, answer is A. 19. Which of the following property is characteristic of the ionic networks too? Ionic lattice structures, network structures. Started with A, high melting point and high electric conductivity. No, because the ionic compound does not have free electrons available. So, yes for the high melting point, no for the electric conductivity. B, low melting point, no. As you can tell, the B is only there with the answer. C, high melting point, high electric conductivity in molten forms. Now, question. What is the key difference between, Alex, molten and aqueous? Molten and aqueous state.
In molten state.
Yeah. Molten versus the aqueous. Or the dissolved.
So ionic bonds all the time in molten state.
Yeah.
They have free delocalized electrons.
No, molten. Anyone? Yeah, in water, dissolved. So does it require the heat? Not heat is not. We can, but not necessary. Heat. This is basically exceeding that melting point of that too. This doesn't require the melting point. So I called it as hot salt. Okay, this is salt water. If that helps you to memorize the key difference between the two. But both of them, you may understand the terms too. I'll give you a little introduction to module 3 later on to you. Hot salt, the molten salt means that all the sodium and chlorides being separated. So it's not the free electron, it's the ions are free. Ions are free to move around in case of that, in the molten forms too. And this, guys, is generally what we can find it out in the lava or the magma. They are highly ionized due to the molten salt of the given rocks. The molten rocks will be full of those kind of salt gibbons too. This is quite different too. I explained it later on too. The chemical structure of this basically given here like this. The water is helping them to separating this like this. But why especially water? As you know, water has the dipole partially negative too. This water is kind of detaching this sodium chloride ion bonding to neutralize the bonding itself. And we call the interaction between this ion to the dipole to be ion-dipole interaction. I will explain that again in module 3 because that's the key point you need to understand. Chloride will then explain separated by the hydrogens, vice versa. Yeah.
Wait, so how does that explain why it conducts electricity?
Because we have now, both of them have now what? 3 ions. This is more like a temporary. And same reason, guys, pure water doesn't really conduct the electricity. Those of you I'm interested about the cooling system or in the computers too, we use the pure water, deionized water to cooling your fans, cooling your CPUs or the computer chips. You can wash that, your electronic devices with those pure water because they are non-electric conductive. But not with the tap water because tap contains a bit of the dissolved salt, chlorine, sodium and all that into too. Copper, maybe some of the metal as well too. Yeah. Tap water conducts electricity, but not pure water. Yeah. 20. So yeah, that was now the STP. Yep. C. Why? Why? No, it's not C. By the 19 was C, but 20 is not C. 19 C, but 20. Why is it D? How'd you go with 20, guys? Did you guess or did you actually attempt? D is the right answer, but why? Which of the following gas would have the highest density at the room temperature and the pressure 25 degrees Celsius, 100 kilopascals too? One thing that you have to remember is that they all have the same volume. And that's the key question that Kirsty asked previous to. Even though they have the same volumes, they all have a different mass. Yeah? And the mass will be determined by the molar mass, basically. So you have to find the heaviest molar mass out of the 4, which would be SO2. Yep. It's same as I have a plastic bag, same volumes all the time, the woolly bags. I have the same amount of the pineapple and apples too, but you know, there will be quite difference to here. Any questions up to this point? Multiple choice? Okay, all right, yep.
So what's inorganic and organic chemistry?
Inorganic is something not dealing with the carbons a lot. Organic is dealing with carbon chemistry, anything the carbon chains related.
So the what? They're both carbon.
The one is carbon, one is not carbon. Okay, let's take 5 minutes break and coming back with the long responses then. 21. Gallium has 2 naturally occurring isotopes. We have 69 and 71. The relative atomic mass of the gallium is 69.72. So a bit of revision that you have to do. Relative isotopic mass is basically the what we have in the periodic table, and we are counting all those naturally occurring isotope percentage in the mass numbers too. In other words, to get that, you have to understand if we have X% is the gallium Ga, the 69 is the one that's given to, then gallium 71 must have the 100 minus the X% given to. All right, or you may just understand it's the same as the X, and that's same as simply the 1 minus X if you want to don't want to deal with the some percentage instead of the 2. So in other words, have you given the 69.72, you can think that here, 69.93 times the X plus that, 70.92 times 1 minus x is giving you the value of the 69.72. Okay, and you can use a percentage if you like to, but you have to times 100 on the other side. Expand the bracket, 69.93x. It's pure mass from now. Not even easy, it's kind of easy too. Therefore, if you find the x, you get the 0.603. This means, therefore, the gallium-69 will have the 60.3%. Gallium-71 would have then the 39.7% like this. Easy. If you didn't know, this is one of the common questions we can get in yearly papers or two, or maybe like in your first coming assessments. The relative isotopic mass. Sometimes we get the mass spectrometry, the graph of it. If you remember those, we measured that. We use a ruler to get the centimeters of that, get the value of those percentage too. B, explain why the chemical properties of the gallium-69 and gallium-71 are identical despite the different masses too. So what is the chemical properties? Will we determine that here? First of all, the mass number. Kirsty, what gives them to be different mass number? Therefore, the isotopes due to the different number of the neutrons. Good. Different number of the neutrons. Now, this means there's no change in atomic number. Emily, what's the atomic number referring to? Atomic number is referring to number of protons and what more? Electrons. Same charge is given to them. Now, key point is this. Electron number is the what determines the chemical properties. So, as there is no difference in the electron numbers, the chemical properties of the isotopes are identical. That should be are identical. They are identical. The key point is you need to define what the chemical, how we determine the chemical properties to. Also determine that what the isotopes and what happens to the isotopes electron numbers by defining the isotopes itself. That's a 2 marks then. C. When gallium atoms are heated, they emit specific frequency of the light. Use the Bohr model of the atoms to explain how this emission spectrum is produced. This is for you, Kirsty, that you have at your school loving you giving these kind of questions a lot, Bohr's models. The key point of the question is, first, you need to use the key words you have to use. One, you have to use the energy level or levels in the Bohr's models too. Bohr's model is the first model that is suggesting that the electrons are orbiting around the different energy levels too, like a shells we described the two, or I sometimes describe that as different apartment numbers, the unit, the levels that we have the two. And once we have two, you have to talk about electrons it gets excited by receiving some heat or heat energy. Then it makes the what? The jumping, moving up, jumping on the higher the energy state or energy level. Now what happens is when these electrons, when the excited electron moves back or down to the lower the energy level, okay, the photon or the light is emitted. The last key point you have to write it down to for this kind of question is the amount of the light energy emitted is same as the difference of the energy levels. What I mean is, if electron jumping from third to second, and having that, if this has like 100 and that's 50 F2, the difference between here will be 50 joules. So when the electron jump back into the high to low, they emit the electron energy with the light of the 50 joules, which is the difference between the two energies here. And depends on how much energy emit, it will be determined that the property, the characteristic of the light. Blue light tends to have carrying the greater amount of energies. The red light tends to carry the lower amount of energies too. Studying physics, you write this one down too. E equals to HF, or delta equals HF. This is more like a physics terms we're using later on, year 12, module 7. Okay. So you may need to talk about quantized energy level transitions of the possibles too, but not necessarily. Okay, 22. Define the term second ionization energy and the right are general chemical equations represented this process and the arbitrary element M. Arbitrary element means that we don't really know, like we don't need to know the actual one too. We just take the imaginary or just think like M as a sample numbers too. So having the secondary ionized energy means what? Started with the ionization energy, it's the energy required to remove the valence electron. But when we say second ionizing energy, means it's the energy required to remove the second valence electron. That's the meaning behind that. Or it doesn't have to be valence, it could be just second electrons from the given structures there. So having that, given the arbitrary element M2, losing one, there's an equation you have to write it down. M, if we're losing one electron, it'll be coming into M plus initially. Losing the second one, it'll be coming into 2 plus by electrons will be here, the forms 2. This is how we can represent the forms 2 in gases and state symbols too. I give you state, gas, and the gas, including state symbols, yes. In general, if we're losing, it's becoming it's element forms too, they'll have a really low boiling point. And it's the key point is that, yeah, it's arbitrary. It's another term. Arbitrary means like highly likely to, but just write it down for now. It's not going to be important too. B, explain the general trends observed in the second ionizing energy as you move across the period. Now, be careful with these kind of questions. This is what I mean by do not memorize those trends, because you will have a tendency of writing down what you memorized 5 minutes before you're taking exams too. And if you just memorize the 10 trends of the first ionization energy, your answer might be like, hey, going across the period, going across the periodic tables and down the group, what happened is that first of all, going across the period, the first ionized energy would be increased. If you said first again, or ionized energy increases due to the greater like charges in the center of the in the nucleus. But that's wrong. It is a second ionization energy. What happened to the group 1 for the second ionization energy, guys? Brian, what happened to the second ionization energy for the group 1? For example, sodium.
Really high.
Why?
Because they only have one valence electron.
Good.
And then the next one's a full shell.
Yes. So that does it require the greater amount of energy to remove the second electrons too? So you're right. Group 1 would have the significant, massive second ionization energies. But what about the second group and group 2? That will be significantly lower. And the trend will be same as the first ionized energy given to. What about going down the group? Going down the group?
It's the same.
It'll be no. the second ionization energy also get decreased going down the group. Why is that? The atomic radius is getting bigger. So easy to lose electrons again too, regardless of even the period. They will be much easier to lose electrons as you know that too. This is how you use what you memorized and what you studied to answer the question or to modify, to reshape your answer to fit it into the question. And yeah, I think every year the exam questions are getting harder in that reasons too. They won't give you the easy question to toss you. See, the second ionizing energy of the sodium is almost 10 times greater than, it's basically what I related to here, the difference of that too. So use the electron configuration, you need to use the configuration of the SPDF or the 2. So let's start here. What's the SPDF or electron configuration sodium, Sean? You don't know.
Right, no.
Second chance.
One S2, 2S2,
1s2, 2s2, 2p6,
yes.
3s1. What about sodium plus? Huh? Emily? What's the SPDF of the sodium plus, sodium ion? Guys, be careful. This is the kind of questions we can give you. 1s2, 2s2, 2p6, and that's it. Why? Plus ion means it lost one electron. Where did it lose? 3. The third one is gone, becoming into plus ions too. So this is how you use your SPDF to explain your answer. Because sodium ion, plus ion, has the old full shell and the p subshells included too. I come back to you, girl. Okay, I know you. I know. I can't see you. Don't worry. When did I not? This is full shell. Basically, taking out of the electron from the full shell is extremely difficult, so that it represented by really extremely high the second ionized energy, which is 100 times greater. Whereas this has the 1 valence electrons, so that it will lose electrons quite easily too. That's the way you can answer the question using the SPDF. Yes. Pardon? Ooh, preferably this. Did you use 2, 8, and 1 and 2 and 8? Yeah, it must be this, preferably.
What?
Yeah. Because you learnt it.
Okay, but you should put that in the question.
Well, that's it, electron configuration.
Yeah, that could be this too.
But we learnt it. Like I've been asking you to use the SPDF since we learnt it. Before we learnt about SPDF, I used the ball. But now you know SPDF is mandatory. 23. Given that, the graph of that too, you probably realize that your data will be really going away from that. And that's in the purpose of that, as we need to extrapolate or just extend the graph. So your line of best fit, even though it looks kind of odd, it'll look like this. I share the dots that I have.
Do you have to do a dotted line?
Yeah. Because you're not given the data. Okay, like this. And no, in here, the line of best fit must be just like this. So for part A, you don't need to show up to here. Part B, you need to extrapolate to figure out to the point too. So I think that's what the question is asking. So don't lose a mark because of scaling. Don't lose a mark because of like a titles too. Title must be included in your answer. So extrapolate your line of best fit to determine theoretical temperature in degrees Celsius at which the gas volume is 0.2. So if you did that, you will see at 0 degrees Celsius, you will hit this, the x-intercept. That's giving you the value of approximately like 300, the negative 300 from the graph. Yep. So that'll be look at the graph. There's a negative like 2. No, it's not 300. 275 around in between. So negative 275 degrees Celsius in the range. Accepted range would be in between 270 to negative to 75 degrees Celsius. That's accepted range. Okay, C, state the gas law. This is definitely B, Charles' law. Charles on TV, T and V is directly proportional to each other's two. I hope you remember all the gas laws by now. D, using the ideal gas law to calculate the moles too. So please use the PV equals to nRT. I mean, there's nothing really special about that too. You get must convert the unit to the temperature to the Kelvin. Then you get approximately, okay, the N would be 0.997 mole, which is approximately like 1.00 mole in the three significant figures. Yep, so we follow the three sig figs. 24. The method, separating the recovered three common component in dry solid forms too. I'm expecting some of the school will getting these kind of questions a lot in your depth studies, working scientifically, writing down the methods too. Your method must be in the order, in the number order too. You must use the very specific tools to justify why you use that. So, for example, you can think about as we're giving ion filling sand and the sodium chloride. Isn't that very similar to the prac we did in here? You have to get all the solid and the nuts too. So first, you need the magnetic separation. Place the magnet or pass the magnet through the mixture to attract all that ion filling. Use the and collect and the set aside on the watch glass on the paper, because you need to weigh them later on too. Two, then you can think about add them some distilled water to dissolve all the sodium chloride that we have in the sand, because we have a sand, there's silicon like a dioxide too. Then what do? We basically stirring that thoroughly, and sodium chloride dissolve that using the solubility differences between the two. Three, what do? We do filter. We use the filtration, using the filter paper, and using the phenol. Be specific about the tools you choose. You can't just say, oh, filter it. How? Your method must be very precise and depth and details about the tools you're going to use and choose. So you use a filter and the filter with the paper and the phenol in the retorting stand. That sand is therefore with insoluble residue will be left over in the filter papers. And rinse the sand with a small amount of water and dry the sand. Now how we dry that is we generally use in the oven to dry the sand. So using the oven to dry the sand and then leave that onto watch glass to dry, and you can weigh that later on too. I come back. The reason why we can't leave the sand overnight means the sand can reabsorb the moisture from the air as well too. So we try to use the some kind of the oven kind of stuff to fully dehydrate the water in that too.
If we put the sand in the oven,
yeah,
does that mean we're evaporating the sodium chloride?
No, so technically all your sodium chloride needs to be like dissolved and filtered through the filter paper.
Why is it wet then?
Yeah, that's one of the random errors we had too. So we try to wet the filter paper again with the distilled waters too, to filterating or taking all the salt water down. But as we know, so sometimes we don't really use the filter paper in that reasons, because it's always leaving some systematic error. But the last point is that as we have a sodium plus salt water, what do you do to get the salt? Do we distillate or do we evaporate? You will evaporate that too, because we are not interested about separating the water. All good. Physical property of the gibbons too. So magnetism, insolubility in the water, or solubility in water, solubility in the waters too. Basically what you have to say. C, yeah, or B. Insolubility in the water, in the sand, or solubility itself, and solubility in the water. And sodium chloride physical property, we can also use that, and the higher boiling point than the water for the evaporation itself. No, rather be, because we have to think about how we separate the salt and the sand. We use the water and using the solubility of those two.
But the separating method was filtration.
Filtrations. Clearly, it would be because we can dissolve the salt. We use the filtration method. So, yes, but going to the more exact answer, it would be our insolubility of salt is the physical property that makes us to separating salt and the sand. What boiling point? Higher boiling point than what? Yeah. Yeah. To what? Yeah, be specific.
So sand is insoluble.
Sand is insolubility in the water, and the sodium chloride is solubility in the water and higher boiling points than the water. So be specific. You can't just say, oh, soluble, insoluble.
But there's no water.
There was a water
Where?
in your method. If you write the method in your, what in your method, yeah, there's a water.
Why did I only get 2 marks for this?
Why don't you get 2 marks?
Yeah. I don't know. Yeah.
Is your method detailed enough?
I think so.
How much details?
Oh.
This is what I have. And what you get later too. That much detail?
Yeah. Well, I know more than that. I just should have put the whole thing.
Why use the magnet? Did you explain? Did you justify? I just said you have to justify the choice of your techniques given to. Okay. Say after performing the separations and the students successfully recovered the 3.15 grams of iron, 7.3 grams of the sand and 4.1 grams sodium chloride given to. So calculate the overall percentage of recovery in the entire mixture. So percentage recovery is simply just adding all that to. So total sum of the masses that we get, we have 3.15 and 7.30, and we have the 4.10 given the 14.55 grams. Now, from the percentage recovery is then 14.55, that divided by 15.00 like this. That times the 100, giving you about 97.0%. This is the amount of the recovery then. Where do we lose at 3%? Maybe the filter paper. Okay? Possibly. But this is what we try to do. We try to dissolve all the salt in the sand by giving excess amount of water. And we are using the wash bottle to re-rinsing those sand as well too. Okay? 25. Starting on the module 2, limiting reagent. I mean, please do it. And you're to get the limiting reagent would be the hydrochloric acid in your proper working out. Easy to do. B, calculate the volume of the hydrogen gas. And 25, so STP situation, SLC, sorry, in situations 2, using the molar volume. 25 degrees Celsius too. So you're to get the answer of the 7.44 liters, or you can use the ideal gas law. You should get a very similar answer as that. Yes.
What's wrong with this? Could I have to use the C equals N over B for that?
N equals to that. Oh, how'd you get the N of the hydrochloric acid? Why did you use M over MM?
Can you use the ideal gas law?
You can. What'd you get?
How grams? What the heck?
Sean, tell me, gram is a unit for what?
Something.
The gram is a unit for what?
Mass.
Yeah. Are you asked to find the mass? No. Then how'd you get mass without the volume?
Someone changed maths.
Someone. That someone must be you then. Not me.
What's the answer for B?
7.44 litre. Now, percentage yield is then amount of 2. So we have done this percentage yield. It's good to know for now. This is basically found by actual yield that we have given. Yield is amount of the products we have given. So, and theoretical. That times 100% like this. So from the previously we have the actual yield of 7.15. That's given. And theoretically we should have 7.44 from question B. So that times 100 would have given you about 96.1%. That is a percentage of the yield that we have given. 26, just N equals to CV, nothing else is to, and get M equals M there too. You get a 2.65 grams. B, outline the valid laboratory procedure to accurately prepare the standard solutions too. I told you to prepare for the standard solution method. Started everything about one, writing the how do you prepare those mass using the electric imbalance, all that too. If you didn't get the full mark for this, yeah, please retry it. The method, standard solution methods. You have resources, you have answers somewhere too. You have to weigh that anhydrous sodium carbonate on the electronic and analytic balance using the watch glass or the weight boat or the beaker. That's the much of depth and detail you need to write it down. As I said, I hope you had fun in the lab, because when you get these in the question, this is not funny. It's actually pretty difficult questions too. That's what I'm concerned about working scientifically a lot of times. That working scientifically is one of the I would say one of the hardest questions you to get, because the questions itself is quite tricky. You have to be imaginative, and you have to bring up your practical skill as well too. Move on, 26C. The technician then pipettes 25 mils of this standard solution into 250 mils volumetric flush and fill it to the mark with the distilled water. Calculate the concentration of new distilled water in the mole per liters too. So taking 25 mils and then diluted, that means that you have to understand, if you don't really understand the situations too, have a think about it in here. Previously, I can draw the flow chart diagrams like this too. You have made in the volumetric flux like here. So this is the examination like strategy and techniques you can do. Previously, you have volumetric flask of the 0.0500 molar of the 500 milliliter of the sodium carbonate. Okay, that's exam technique you can do. Question C is asking that, hey, from that, they took out the 25 mils. So they took the small amount of the 25 milliliter. Now, question, quiz. Kirsty, what would be the concentration of these 25 mils?
5.55.
Yeah, 0.05 or more, because we took it out too. Then dilute it into the big batch of the 250 milliliters like that. I knew someone's going to ask me that question. Pipetted out means that I just took the 25 mils from the solutions too. Did I change the concentration? No, this is why the concentration is the same. But what if if I dilute it, it'll be changing concentration. Now, use this kind of techniques later on in year 12 standard. You get like up to 10 stages of the dilution factors. Yeah, I'm not kidding, 10 stages. 2 titration in a rows. One is back titration, other titrations to dilution, taking out of that too. Really confusing. Even the question itself is 1 page wrong. The question is 1 page.
Well, the question itself.
Question is 1 page. Yeah. How long is working out? The working on is like 2 pages, but they're just purely doing that too. That's in HSC.
How many months would that be?
I show you.
How long does it take?
How long does it take? Depends how much we practice.
What the heck?
A minute. 7 marks.
All that for 7 months?
Welcome to year 12 chemistry. Yeah, a minute.
Well, what does the VV mean?
Volume per volume, milliliter per milliliter times 100%. Technically, guys, you should be able to do this question because there's no theory behind it. We did everything.
Like, if you just go through one by one,
Yeah,
just get it.
yeah. But remember, this is the HSC examination. You only have technically 10 minutes to do this
So
question.
how long would you take to do
Me, 10 minutes.
10 minutes?
Yeah.
Oh, yeah.
Rechecking, I'll probably take about 15 minutes. It's really difficult. It's not difficult, but it's really difficult to understand what is going on in the words there too. So I recommend students to do these kind of methods. Use the small some flow chart or diagrams to simplify the information given to. The key point is that if you're doing this kind of method, summarize the point in the flow chart, you don't have to read that 3 times, 4 times. A lot of time you're losing time because you are rereading these words by words again too, and you try to think about, and you're lost in the middle of that. You're like, where was? Okay, where am I? Like, whoa, I don't really get it, and you start rereading that too. Not kidding. Some people would spend about 10 minutes just reading the question. How do I know? I've been looking at the students like, not writing anything, just reading, and got mind blank. Yeah? Well, it's not funny if you have to do the questions yourself too, because I'm trying to give this question for your yearly paper later on. Yeah.
This exact question.
Yeah.
Alright.
2021, I can tell you, 2021 HSC, question 35, 7 marks too.
320
Try it. I'm glad if you try that. HSC
HSC question.
question.
Question 34.
Yeah. It's not easy, but that's the goal. That's the goal. One more thing. Been hearing heard about so much rumors saying that you trial papers, HS trial, which is your school internal final exam, is harder than the HSC. Okay, who hasn't heard that? Who has heard like the trial papers are harder than HSC? Yeah, all rumor. HSC is actually getting harder than trials nowadays. Yeah, like I don't know who spread the rumors like that too. If you haven't seen like HS papers nowadays from 2023 to 25, they're not easy. They sometimes be harder than some of the trial papers. Only exception is if you're doing CSSA paper. I feel really bad for those Catholic school kids because they're doing that papers without any choice. Okay, not you. Okay, some Catholic schools actually must use in that, or some of the school Anglican schools using their CSSA as well too. Another schools is that if you're in the highly selective schools like James Drew's, Homesby Girl is not really. They're doing the standard way too. No Sydney boys is okay. Girls sometimes. Yeah, sometimes harder too.
What's CSSA?
That's a Catholic school paper.
So why is it bad?
Why is it bad? Because those questions are actually, some of the questions in the CSSA, we call it Catholic school trial papers, are actually harder than trial exam, HS exam itself.
Like purposefully?
Yeah. And it's kind of funny that Catholic school kids are not that smart. Overall, I'm talking overall because they're not selective. Can pay to get in there too. So, I don't know. It's been known. So, in your trial preparation, which is going to be next year too, I don't really give a lot of CSS paper in that reason because I don't want you to feel like discouraged by those doing the harder papers too. Standard is always it must be your HSC papers all the times too, because all the trial papers, sometimes in your school exam, we're using those HS paper as our standard. And I will show you this year 2026 HSC paper on the day it's released. We haven't got the exam dates yet. It's about to release in 2 months later too. They will get the examination dates. Yeah.
Wait, do people that did the HSC say it's hard because they didn't study, or is it because they need extensive knowledge of it?
Could be two reasons. It could be really hard, and it could be also be like depends on subjects you're talking about too. If you're talking about 4-year math, extension 2 mathematics, chemistry, who's saying it's hard? Depends who's saying that. Okay, majority of people would have said like, oh, it's a doable. I could do most of the questions too. I have a couple. Maybe I couldn't really. I'm not too sure about how to answer them too. And most of them saying these kind of phrases would get a band 6.
Like you know how the curriculum changed for our year?
No, not your year.
Wait, so wait, what?
You're not. The year and after. You're after, which is year 10 now.
No, it isn't.
No, you're not.
Wait, what?
You're not. No, you're not.
Our whole math curriculum.
Math is not the science.
Oh no.
Well, they're different. Come on, we're not same department. We're completely different too. No, come and think about it. Like you change the math, you change the chemistry. You're so poor things. You're poor things. Like change. You're a guinea pig and lab rats dealing with all the changed syllabus. Yeah, this is really bad. You're doing everything's new means. You know what happened then? You can't use any past papers.
Yeah, we make the past.
Yeah, you're the one of doing the past. You're making the past paper for the event. Think about it. You're doing the past. You have no past paper for math. You have no past paper for chemistry. I always feel so bad. So at least we have a bit of like humanity left over this too. So you're not the first year of the changing syllabus of chemistry. It's actually chemistry is changed for year 9 this year. They are the first year to change the chemistry syllabus.
Is it gonna be like harder? Like,
Yeah, I think it's gonna be harder. There'll be a lot of pracs, more working scientifically. Now we try to make working scientifically be like 40 to like 40% of the whole internals too. So rest of it will be just theory exams. Now what's going to be happen? One, it's not about time, but just shortly too. There will be no SRP. Oh, is that good? No, there'll be harder things coming. Depth studies, 2 depth studies in a year, possibly more. So they're pushing. Not you. Don't worry, guys. You guys are lucky. You're blessed. You're the second last generation of the year of the taking this syllabus before we changing it. The last year would be this year, year 10. But unlucky for those, they will change the syllabus of the biology and physics for year 10 this year. They will get a new syllabus of bio and physics next year then. Not you. You're blessed, I'm saying. You have no change except math. Like science, I can give you good news. No change. We can safely use all the past paper from 2019 to 2026. How many years? That's 7 years worth. Oh, guys, you have 7 years worth of the papers to try. Plus that 7 year worth of the trial papers you can try. Plus that 20 papers that I'm gonna give you for your trial paper as well too. It's a different paper. I'm giving you about the 50 to 100 sets of the trial papers, by the way. You see, like in your sister's booklet.
oh yeah.
Yeah, it'll be double of that, by the way.
Oh yeah, it was like this.
It'll be double of that this year and next year. I'm kind of well known for like giving lots of the resources, by the way. Yeah, but
I do make your own.
yeah, I do use some school past papers of the if I need to, because that's kind of really good resources too. Because sometimes schools using the recycling the past papers, they do. If in that case, why would I bother to make a new papers? Because that's basically exact same papers. Carlingford, you get the exact same kind of papers. That's what too. So sometimes you just need to memorize the answer that question. You get the full mark of that too. It's so easy to get a mark. Because I'm sorry, your school teacher's kind of lazy to make the new questions too. Because it's such a hard work to make the new papers, new questions too. It takes a lot of time. Making one paper. Teachers sometimes spend about a month to make a new trial papers. We get rechecked by the others. Even that we get like recheck. Even get 3 rechecks too. There are some errors in the questions too. This is why many of the private and public schools are buying the papers from the third parties, and I'm giving you those third party papers, which is I call them mother papers, because they are basically getting 3 or 4 papers from different companies. We sometimes using the whole paper itself, sometimes mix using some of the questions too. So you need to know the style of each of the paper for the trials too. That's a later one for the trial preparation. So they have no life, at least like 12 hours of doing the exams every week, sitting down, and maybe 20 hours of those in preparations too. That's next year, don't worry. Next year. This is why I've been nagging my year 12 so much this year too. I've been yelling at them, study now. But you too, study now, guys, okay? 27. Group 16 hydride, water and hydrogen sulfide. Water has boiling point of the 100 degrees Celsius. Hydrogen sulfide has minus 62. Explain the significant difference in the boiling point with the direct reference to the relative strength and types of the intermolecular forces. Pretty easy if you understood that water has the strongest intermolecular force called the hydrogen bonding, whereas the hydrogen sulfide has, even though it has band shape, it's not the dipoles. It highly likely to be dispersion forces too. Even though it's a dipole moments too, it's a really weak dipole because it's everything related here. Compare the electronegativity of the covalent bonding components. Oxygen, hydrogen, I told you. Number 2, the last. The joining between that would be a very unequal sharing of the electron forming the polar covalent bondings. Sulfur and oxygen, they're basically in the same group. So there's not much electronegativity differences too, even though oxygen would be slightly greater than that too. So making this slightly polar, but it's not as strong as a H2O. This is the whole purpose of the questions too. Please study this. This is a very important content because you will get lots of these in HSC, in trial papers too. If you get a full mark, well done, keep it on too. If you did not, try harder to get the full mark the next time.
So it's like most of the questions that come out of like papers, like is it gonna be like about ammonia, hydrogen sulfate, and then water?
I give the easy one though, but if I'm addressing a phosphorus instead of that too. This is why don't memorize the answers. Memorize, if you do need to memorize a template of how to answer those specific questions too. And reshape the template as you answer some of the questions time to time too. And you know, this is a very useful tool to shorten your exam time. For this kind of test, how long did I give you? Hour and a half or 2 hours last time too? You're supposed to finish this paper within an hour and 40 minutes. And I think it's doable. If you're fully prepared, if you know what to write, you know how to deal with the answer, it's like here. As soon as you read the question, you click, oh, I'm going to write this. There's no hesitation how to write the answer. That's the coming out from the practice. And how many questions do you have to practice? Brian, guess. How many questions do you need to practice to get into that level? You see the question, you click, you answer the question straight away. Quantitatively, how many questions do you think you have to practice? 100 only.
10,000.
Ooh, that's too much. You have not enough time. I would say 1,000.
1,000.
Yeah.
All the same question.
No, same same style with similar style or the very similar style of questions
So,
too.
like after a while.
But after having the 100, even that too. I mean, you would know.
10.
Because you're smart.
No, but Leo, if it's about like the same thing.
It's not the same thing. There may be a different type of questions. You're not answering this question 100 times. No, you're not answering the same question 100 times. What an inefficient way to practice, by the way. Would you like repeating and writing that as 100 times? And what if you get something different too? Oh, I'm still writing that 100 time practice question down too. No, I'm waiting like you do like different side of the paper question and again too. This is what I'm trying to do with you guys too. I give you like very simple, similar structure with the changing word, change the example given to because how you need to answer those questions. I'll be making like some kind of machine to answer this question. That if you have a template to answer this specific question by practicing that 100 or 1,000 questions now, it's so easy to just answer that question. It's basically you're filling the gap, filling the underlying some of the things too. That's the level you have to be in, get into like a 90% above in your school exams. It's like you have input, you have output straight away. There's no delay. There's no hesitation to answer that questions. Same as playing. I think it's really similar to playing the basketball. Think about how many shoots you have to practice to be in the match. I think you have to do more. You have to practice more than the actual match itself to do. Because the actual match, actual exam, your nerves cracking, and there are so many variables that happens to you can really get injured too. Guys, by the way, in the exam period, you really get easily sick, as you are mentally, physically hard. Really like in the hardship too. You may get like some sleep deficits. You don't really get a lot of sleep. Seeing the year 12 now, they only sleep 4 hours a day.
I can't do that, bro.
That's why they're so short
No.
now. We're evolving now. Just study.
Why? Because you slept a lot. I'm sorry, they gotta get shorter now then. No. Don't even talk about the evolution in my from the that's a biology again too. It's all genetics. That's all I can tell. All right. 28. The mass of the water from the givens too. I think Kirsty, this is what you asked me earlier there too. Yeah, we did that. I'm sure we did that. Given here, 5 gram sample of the hydrated magnesium sulfide. Hydrated means that it contains the water molecules per the magnesium sulfide too. Now, and heated that, the final mass of anhydrous. Anhydrous means that all the water has been removed. So started with question A. Mass of the water lost during the heating is mass of the H2O is simply because the mass of the MgSO4 and XH2O minus the mass of the MgSO4. This is what I mean by dehydrated or anhydrous. Hydrated and basically given that 5 grams minus 2.44, so easy, you get 2.56 grams of water. Yep, then determine the value from the formulas given to. So what do we know? Can we get the N of the MgSO4 for B? Yeah, mass over molar mass. 2.44 divided by molar mass everything, so you get 120.38. You get 0.02027 mole. Okay?
Wait, what's the 158?
Oh, that's I get added up the Mg and SO4. Yeah. How about the N of the H2O? How to get the number of moles of water? We do know mass of the water is now be 2.56. Same formula. 2.56 divided by, if you like to, 2.108 plus the 16s like this. Then you get the 0.1421 mole. Comparing the two moles, so N of the MgSO4 divided by the N, other way around, sorry, like this, MgSO4. The ratio between the number of moles of between water and magnesium sulfide is 0.002027 to 0.1421. Can you see that? In the whole number, this will approximately be 127. Therefore, X is 7. Easy?
Easy.
It's actually easier than you thought. And we
How do
did.
you know that's hydrated salt?
It's given.
It just says hydrated.
Yeah, and it has X and the H2O, the dot.
Does that mean it's salt?
It doesn't mean that it means that it's hydrated. It means that it has a water kind of surrounded to.
Or salt is solid.
Yeah, but the salt can be moisturized.
Wait, I'm confused. So why there's an X in the H2O?
Hmm?
What is the X?
X is the amount of the water. So what that means is, if we have MgSO4, the compound that we have the two, there are 7 water molecules that are surrounding this. 1, 2, 3, 4, 5, 6, 7. They are surrounding this. Yeah, the perfect number, isn't it? Yeah, it's surrounding this. Per MgSO4 it has that too. That's meaning of the hydrated salt.
Also finding how.
I mean, how many are surrounding per the MgSO4? That's the meaning of the question given. So,
What does a dot mean?
dot means that it's not really chemically bonded. That means again they're connected, like a bridge between the two. Specifically, this is known to be ion dipole bondings or interaction too. Not now, but module 3, yes, you do. All good? Say, state the correct systematic name of this hydrated salt. Okay, systematically then, we can name that uses 7 that given to. Oh, it's actually like, it's hard to know. The name of this is known as magnesium. Magnesium and sulfate, up to here is obviously, yep. But 7 in Latin and in chemistry we use hepta and hydrate, as we're given the name of that too. We're given the name mono 1, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, and deca or dec 10. That's Latin, by the way.
Wait, so again, back to the dot.
Yeah.
Doesn't mean they're chemically bonded yet.
They're more like bonded, but yeah,
So they're bonded.
they're bonded.
So one of
They're
them-
like in a package of the gibbons too. Like this.
But they just put it in that form because there's no specific name for it.
No. The reason why we separate that, are they like in the water, is a part inside of that? If we have water inside the MgSO4, we got put the H2, we can write it as MgHSO6. We can't do that. But the reason why we don't write this instead of like using that is that because they're not really MgS supposed to be MgS4 itself. They'll be like in the packet of that too. It's just the water gets surrounding them, it's chemically bonded inside.
It's showing it's an intramolecular force.
More like
Intermolecular.
it's an intermolecular force, but it's coming in the package of they look like one molecules itself.
Bonded
This
or
is called the complex ions, by the way. As you can see, like it's kind of complex in forms too. All right, last question. Uranium U-238, 92. Going through the what decay? The alpha decays too. So I should like easy give an easy method. Start with the 4-2 helium, and then just do simple math. On the top, 238 minus that 234, 92 minus 2, 90 gibbons 2. Use your periodic table, you will find this is thorium. And that's it. I don't mind if you put the gamma rays after that too. Sometimes we get the gamma rays, but not necessarily put this one. Now B, for you, the radioactive isotope has half-life to 14 days. If a sample initially contains 48 grams of the isotopes, calculate the mass of the isotopes that will remain after exactly 56 days. Now, there are two methods. One, use the visual method or the flowchart method to figure out how many half-lives you go through to. Two is the mathematical method. I don't mind it too. Half-life, start with understanding that too. Half-life means that the time taken to decrease the initial amount to the half. So if we start at 48 grams like this too, after one half-life, this is how we write half-life that too, it will be decreased into 24 grams. Okay, another half-life goes on to that it will be half of this 24 becoming into 12 grams like this. Another half-life gone, becoming into 6 grams like that. So if we're having 3 consecutive like in the half-lives too, it would decrease by 48 to the 6. Now, if you don't really, if you're not really confident with the dealing with the mathematical terms too, this is the flowchart method that I'm talking about. And one thing that you have to understand there is 56 days. So we have a given half-life of the 14 days. Extra time given as 56 days. Simply divide the 56 by the 14, then you get 4 half-life that too. So you can draw another one without doing any math. That's giving you what? 3 grams. Will be given to. That's a method you can do. Or the second method is use a bit of mathematical terms. You can do like this. This is what we prefer in year 11 and 12 standard or even physics standard too. Then with a number of the half-life is same as the t on half, t divided by t over the 1/2 like this. Okay, that's giving you we have 56 days divided by the 14, giving the 4 half-life repetitions there. Now, this is then, it's actually working as this. Mass is equals then initial mass times the half times the n like that. Or it could be n is equals to n naught times the half of the power of the n. More like a mathematical term we can use. So in terms of here, initial mass that we have given is 48. That times half of the n, 4, power of the 4. Put in your calculator, you get the same answer, 3 grams.
What does M represent?
M represents mass.
No, what does N represent?
Number of moles or numbers.
So, but why do we need mass? Or why do we
This is originally what we're using in physics and mathematics. You will kind of program about decay series in there's some math later on. Extension 1 or advanced math as well too. That's a decay formula. Yeah, advanced. I'm just using the M instead of the N.
So M-O,
Mm-hmm.
what's the O?
Initial mass. O means that the starting mass or the starting number of moles all the times.
So M-O are together.
Mm-hmm.
Is that a H?
N. Okay. Okay. I'll explain you what's going to be happen for next week. First, okay, I will introduce the new marking system from now. So, I should have a sample. Okay.
Oh, yeah.
This is a report that you will get from now for every single test. Don't worry about this one too. Okay, that you will get marked by the programs. I'm using a bit of the AIs. It's not 100% accurate though. So I call this as a draft marking. So you get the draft marking report from the you can generate it, and this will be sent to your personal email. And I will collect the consent from your parents that whether they want to send your report to them as well too. If they say yes, I will send the report to them directly as well. If they say no or no response, not your consent by the way, it's your parents' consent too. Okay, I won't send them. But you will get these as soon as you finish the papers too. It takes about approximately like 15 to 30 minutes to mark the one papers too. So the day you finish the paper, you will get the results back on the night or the latest by next day. But the issue with the draft marking is, as you can tell, like using the AI, even though it's kind of well developed too, sometimes due to your messy handwriting, and they can't it's actually meaning too, and sometimes they can't really recognize the numbers and letters really well too, and that was an issue. I know that too. So in that case, I set it up to be like in that kind of question, I just set it to like that question needs to be rechecked by the teachers or like some of the tutors too. So there will be a sections that you will see like which question you need to recheck that, which means even though you get a marks like that, you have a chance to get an extra mark from the rechecking those questions too. This is why I call it the draft marking. So you may think this is the lowest mark you to get. Depends on how you reflect, how you comment, and you come in and see me for the discuss about the question you want to do. You can get extra mark, and that sometimes give you like extra 10 or 20 marks. Depends on how many questions get not really marked well too. I don't really fully trust that marking because it's good, it's really useful tools, and I only use it for the efficiency and try to give you the marks back really early to you. So that you know you have to keep your rhythms to studying that too. You know what's happening, what's coming up next time. So every single time you test, including the retest and any half yearly or trial or your yearly papers, we're going to try that too. You get the marks back into your report and your marks back into your emails, as I said too. Another thing you will get is every single paper you're trying today, you get a personalized practice questions like this. Now, this is automatically generated question based on the question you got wrong. And this will be sent to your email as well too. But if you like me to print that, yeah, you can ask me to print this one as well. I can print and give it to you. And these are the questions that is not different. I'm not the same, exactly the same to the question you got it wrong. It's a reworded question more likely, but this is basically personalized paper. Everyone would have the different paper, different questions, because everyone has a different like answers and different weaknesses too. Based on the weakness, you get the question back like this. And at the back of that, sample answers being attached. So you always can see like the sample answer at the back as too, detailed sample answers. The whole purpose is that we try to find your weakness and refine that, can fill in the gap as you move on to. And if you do more trial, you do more retest papers, so you get more resources to do it too. So you get a bunch, and that's what I mean. You could probably get double of your sister get. Because I didn't do that in like previously up to like last year, and I kind of invested like, and I'm working on some engineers and making on these systems too. It's a draft, by the way. It's not perfect, so I'm still working on to make it more like a reliable too. But still, I found it out. The draft marking is not too bad, and we can still get some reliable data based on that too. And as you know, AI is getting more developed. I think I'm assuming that by next year, when you're doing the trials, the marking will be more accurate, and that's what I'm expecting for the next year as well too. Which means from now on, what you get, even though this is kind of class session of the 6 to maybe the maximum 6 people too, you will get the personalized the reports and the personalized the question you can practice at home. And there will be some extra question and homework that I'm giving you as well too. In other words, you have a bunch of the questions to try, bunch of practice to do. And that's what I'm here. As I have less stress of the markings now too, because marking is kind of, to be shared with you, it's kind of stress for the teachers. Because marking one paper, it takes about, if humans marking it, it takes about 30 to 40 minutes per paper. And we all, as you know, same for the school teachers too, we all make mistakes. Your marking sometimes be really odd, and that's kind of stressful to keep doing that too. But one important thing is this. Once you get the reports back, you don't just open and check your marks and close it. No, don't do it. This, as I said, it's a draft marking. You need to go through each of the questions by comparing your answer to that, whether that's a matching or not to, first of all. And especially for the question that was eligible by the systems too, you can recheck it and come and see me in your own time. So you need to organize your time. It could be before and after the class too, or during the class when we're doing that too. Like today's sessions, you are more than welcome to discuss about the question, bringing up the questions about you're not too sure why you lost the mark to, but that is how you improve. You're not improving from something you're good at. You always get improved from something you're bad or not really good at yet. So this is the whole point of introducing these systems now. Please use that, and I'll probably send the email to your parents by tomorrow, so they will get the notification of a new system of the marking stream. For the papers you've done, it seems like no one actually passed to get the 50%. I don't know. I have to check yours, Kirsty, but yeah, it's kind of coming out to the lowest mark too. As I said, we won't do the same paper for the retest, as I explained everything. And what's the point of the memorizing answers, rewriting the answers down? I know you can initially do it if you want to pass the 90% too. And that's what I mean. What's the point of getting 90% for that kind of test? So your retest gotta be similar style, but different questions. As I really want you to practice these questions and some other questions that I'm giving you as well too. I haven't decided, made my mind to whether we're moving on to module 3 or doing another test next week. That is something I haven't made my mind yet. But I prepared everything for module 3. Your homework, your revision question, work's been ready for that, and it's sitting down. It's basically at the back of the oil cupboard. It's there. I printed everything last week. But it's a matter of whether you are prepared to move on to module 3. What's the point of moving to another module? By the way, when we're moving up to module 3, you will get like 200 questions of practice every week. Because I will, as I said, I'll push you to memorize all the reaction templates. In terms of that, you should know now if a certain reactant, you should now know that's making some product of that and that straight away. And as I said, that requires a lot of practice, not 100, maybe thousands required to. Because it clicks you and you get the input as the output straight away. So, how many people finished the homework that I gave you last week? I know you haven't got it. Yeah. You finished it. Finished it? We're gonna do a retest next week in the class time. During the class. That was my standard. That was my parameters, by the way, too. If you just could finish all the papers in here, including at least like 3 out of 5, I was going to move on to module 3, but you haven't done it. Okay, this guy lost it. Yeah, I'll give it to you.
I have like so much paper, it's like stacked in like.
Buy a folder. Organize them. You get more. I'm not kidding. Like, Sean, I'm giving this much. You gotta actually say this much at the end of the HSC.
I already have that much.
Do I? This much then? Maybe that much. It'll be a tower of the A4 papers too, because I know, I counted how many pages I'm printing a month. Apparently I'm printing like 10,000 every month. And yeah, the guy who fixed the printer came to me like, what are you doing in here with the printers too? Like, why are you so much print? And he was recommending me to buy the new printer. I'm like, okay, that's too expensive too. It's 10 grand, by the way. So I'm like, yeah. I'm like, okay. I have no money for that yet. I'll buy it next time. Yeah, so he's seeing me like every month to fix that printers too now. But okay, I don't mind. I don't mind giving the papers to if that's helping you to improve. But don't waste that. Don't waste that. Don't use that to. I know it's gonna be really good feels to if you after finished HSC, if you want to have a ritual of the finishing HSC, you put everything into like there's some. Oh, that's what I did by the way. I put every resource into the drum and we burned that, and we had a barbecue with that too. I have so much resources to burn. Oh, so fun! Having the barbecue on the top of the grill. Oh, that was the best. Smells like a meth. Smells like a science over there too. You can actually smell some of the ink coming out of that too, because the highlighters and ink and that. But don't save that for that. That needs to go to here. All right, let's do a couple of the practice questions before we finish the class.
Thank you.
You're welcome. The sample answer for this paper will be uploaded to your Google Classroom tonight. So you will get the see the answers today. I would like you to try. Let's do a question. Some like little hard questions. Okay, let's do just one question today. Question 4, please.